Hi everyone, I'm Prasant Adhikari here to present my fourth project on loss modeling and rate making. In this presentation, I critique the intern's report on the 1500 general liability claims data. Rather than immediately criticizing the report, I first constructed the analysis from the raw data in R to verify the calculations and understand the reasoning and identify which weaknesses are truly material. And based on that reconstruction, I will discuss five key weaknesses and show how the analysis can be corrected or improved. So before discussing the weakness, I want to clarify the standard I use. The assignment required analysis of indemnity loss, total loss, the impact of revised policy limits, and the treatment of missing policy limits. It also specifically required that if a probability model is proposed, it should be justified or parameterized. So I evaluated the report by reconstructing the analysis from the raw CVS in R programming and checking the descriptive statistics, reproducing the policy limit calculations, testing the missing limit issue, and fitting candidates distributions myself. My first step was to reconstruct the report's key descriptive statistics from the raw data. The intern's mean summary numbers were largely reproducible. For example, mean losses was about 41,208 and the mean total losses was about 53,797. Both distributions were also extremely highly skewed and leptocortic with skewness above 8 and cortosis above 100. So the basic descriptive conclusion that these data are highly skewed and non-normal was correct. My first critique is that the report mentions candidate severity models, but does not statistically justify any of them. That matters because this dataset is extremely skewed and heavy-tailed, with loss skewness of 9.16 and courtesies of 145.17. In this data, model choices cannot come from the histogram shape alone. When I reconstructed the analysis, gamma maximum likelihood fitting was unable, while log normal was more feasible, but still imperfect in the upper tail. So the correct improvement is to treat these as candidate models and justify the final choice using parameter estimates and diagnostic evidence. To test the intern's model claim, I compared log normal and gamma using both KS statistics and QQ plots. For loss, log normal had KS statistics of 0.0265 versus 0.3931 for gamma. So log normal fit was obviously much better. And for total loss, log normal again outperformed gamma. Although the fit was still imperfect in absolute terms, the QQ plot still the same story. Log normal tracks the body of the data better, while gamma departs more strongly, specifically in the upper tail. So the report should not have presented gamma and log normal as equal plausible without formal comparison. And this slide shows how analysis can be improved. I explicitly estimated the model's parameter for both candidate distribution. Log normal parameters were estimated by maximum likelihood estimates, while gamma was estimated using MME, method of moments, and the log scale histograms also provide much more informative view of the fit than the raw scale histograms in the report. So the corrected analysis is not just to name candidate models, but to estimate them, diagnose them, and then justify the preferred model. My second critique is that the policy limit analysis is both inconsistently defined and poorly interpreted. First, the report's charts are level as adjusted total loss, but the page 4 numerical summarizes match capped loss only. In my reconstruction, the first 1000 capped losses mean was 3811.94, and the last 500 capped losses mean was 24,998.07. But the corresponding capped total loss were much higher at 10,813 and about 49,000. Second, the file is essentially ordered by claim size. The Spearman correlations between row number and loss is 0.9998 mean, and even before capping, the first 1000 claims had a mean loss of about 7,784, while the last 500 had a mean of about 108,000. So the report should not interpret these two groups as neutral subsets. A better analysis would clearly separate cap loss from cap total loss and explicitly acknowledge that the policy limit exercise is applied to pre-sorted data. And my third critique is that the missing policy limit discussion is generic and not data driven. The report says that treating missing limits as no limit may be mm, unreasonable and suggest imputation or sensitivity analysis, but it never checks whether missing limit rows actually differ from the rest of the data. In my reconstruction, claims with missing limits had lower mean and median loss than claims with observed limits, and none of them were censored. The box plot also supports this pattern. Both groups are right skewed, but the missing limit groups does not appear systematically more severe. So the report should have supported this discussion with evidence from the dataset instead of giving only a general warning. And my fourth critique is that the report does not analyze the censored claims deeply enough. The dataset includes a censoring indicator, and there are 34 censored observations, or about 2.27% of the sample. Even though that proportion is small, censoring matters because it occurs in the upper tail, and severity modeling is most sensitive. And in my reconstruction, censored claims had a mean loss of about 217,000, almost 218,000, compared with about 37,000 for uncensored claims. And median losses was about 100,000 versus about 11,000. Their mean ALAE was also much higher, about 37,200 compared with 12,000. The box plot makes that separation visually clear, so stronger reports should have explicitly discussed how censoring affects the right tail and interpretation of the any fitted distribution. So to improve the report's treatment of censoring, I analyzed the censored claims directly and then fit a censoring adjusted log normal model. First, censoring occurs exactly at the policy limit. In all 34 censored cases, the observed loss equals the policy limit. Second, those limits are substantial and with a median of 100,000. Third one, I accounted for censoring both fitted log normal parameters increase slightly relative to the naive fit on the observed losses. Um, that means ignoring censoring slightly understates upper tail severity. So the stronger conclusion is that censoring is not just a descriptive flag in the dataset. It is a real tail modeling issue that should have been explicitly addressed in the report. And my fifth critique is that the graphical analysis is too weak for modeling claims being made. The report realizes mainly on raw histograms to support statements about skewness, tail behavior, and possible distributions, but these data are extremely heavy-tailed. Loss ranges from 10 to over 2.17 million, and total losses range from 135 to over 2.3 million. With very high skewness and kurtosis in both cases, and because of that extreme range, the raw histograms compares most observations near the left edge. They are fine for showing that the data are right skewed and not normal, but they are too weak for evaluating candidate severity models. A stronger report should have used log scale histograms or QQ plots and other fit diagnostics to assess model adequacy more clearly. To improve on reports graphical analysis, I used a fuller set of diagnostics for both loss and total loss. These include fitted densities, empirical versus theoretical CDFs, QQ plots, and PP plots. Together, these diagnostics show that log normal fits better than gamma for both variables, while gamma departs more strongly from the empirical distribution. They also show that total loss is harder to fit than loss, especially in the upper tail. So the improvement here is not just adding more plots, but using the right plots for model assessments. That gives much stronger basis for an distributional claim, for any distributional claim, than relying on the raw histogram alone. So to conclude, this project showed that the main weakness in the interns reports were not just stylistic, they were methodological, and they affected how the data were interpreted. A stronger analysis begins by taking the structure of the dataset before making subgroup assumptions, and it then separates indemnity loss from the total loss clearly, tests missing policy limit assumptions, using the data, and treats censoring as a real operational issue rather than descriptive photo. Footnotes, and finally, it uses formal diagnostic evidence, not just raw histograms, to justify model selections. So the broader lessons from the audit is that careful statistical validation prevents casual assumptions from hiding meaningful tail risk and understanding the financial exposure in the portfolio. Thank you so much for your time. This is my critique. Thank you.